Good morning to one and all present here. This is Padmavati from Department of Computer Science Engineering. I'm working in Sri Venkateswara College of Engineering, Bangalore. And today we are going to discuss a topic in digital image processing. And the topic is global processing. See, global processing comes under edge linking process. Once you find the edge, then you can link the edge using two types of technique. One is local processing and the other one is global processing. And usually global processing can be done through Huff transform. And here, the global similarity measures can be calculated using the strength of gradient operator, which is used to produce the edge. Direction of gradient operator can also be calculated. And here, the edge linking by local processing can be calculated by taking a point x comma y in an image, which is already operated by Sobel edge operator, and here T is called as threshold. In the edge making, you can take an image with two different points x comma y and x dash comma y dash. In order to link them, you can calculate the similarity measure. For example, if you calculate the curl f x comma y minus curl f x dash comma y dash, that means the curl point of both the images, that is the difference of both the images, is less than or equal to threshold, then you can calculate at one point, and if it is less than or equal to the operator value, then you can go to the other thing. That means either you can take an image or you can take a background. So why we are going for edge linking and boundary detection? Because it yields pixels which lies on the edges, and also it characterizes the edge completely because of noise which breaks in the edge from non-uniform illumination and some other effects which introduce some spurious intensity discontinuities. Thus edge detection algorithm typically is followed by the linking procedures to assemble edge pixels into meaningful edges. So whatever the pixels which we are getting in an unusual way, we can able to get in a meaningful way. So the edge linking process is a process of combining all the edges to form a meaningful shape or boundary. So this process is called as edge linking. And now we are going to see the transforms, global processing using Huff transform. See, if you can take n number of points and you know the value y is equal to mx plus c, and which is nothing but the a straight line equation. And here you can just take a straight line, and this is the point where you are taking, this is your slope of m1. See, Huff is an author. He proposed an approach which is called as Huff transform. Initially he considered a point x x1 comma y1, which is a straight line equation where y is equal to mx plus c. This is nothing but the intercept, and m is nothing but the slope, which is satisfied y is equal to ax plus b for varying values of a and b. So we can write this equation in terms of, instead of x and y, we can use a and b, and we can calculate the parameter space. And here, this is nothing but you can, at different points, you can pass different kinds of straight lines, and you can calculate different parameter space in order to satisfy the condition of the global processing transforms. And here you are having a two cases. One is a straight line in xy plane which is mapped to a point in your y is equal to mx plus c plane. Otherwise you have a case 2. If we have a point xy which is, that is mapped to a straight line, that is mapped to a straight line in a MC plane. So here you can identify either a straight line is mapped to a point, or a point is mapped to a straight line. So both the conditions are to exist in two edges of the algorithm. So one is the straight line in xy plane, which is mapped to a point in MC plane, where M is the slope and C is the intercept. And here, second case is a point in an xy plane that is mapped to a straight line in MC plane. See here, either this straight line maps to a point or this point maps to a straight line. So this is what they are trying to explain in the condition. And here we can consider the Hough transform. Before that, we need to understand what is an image space and the parameter space. See, image spaces are lines, points, and collinear points, whereas the parameter space are only points and lines of intersection. And here, the implementation of Hough transform is nothing but the entire MC space is subdivided into the number of accumulator cells. So this constitutes about the Hough transform, global processing using Hough transform. And we know we can calculate using the theta parameter also, that is x cos theta plus y sin theta is equal to rho. So that parameter also we can consider, and we can calculate if it is a horizontal line. So horizontal line means the theta value will be 0 and your rho will be positive, and it will be x intercept. Since it is a horizontal line, it is an intercept. If it is a vertical line, your theta value will be 90 and rho is positive, and it is called as y-intercept. So these are all the various conditions you can apply in your global processing using Hough transform. So here we have completely discussed about the global processing using Hough transform. Thank you.